Hello, math students. Today we're going to tackle actually a new formula, a second formula to find a derivative. So far, if you look right here, it says we already know that the slope of the tangent line at any point x f of x is given by the limit as h approaches 0 of f of x plus h minus f of x all over h. So this one we've already been using. Today I'm going to teach you a new formula, and this new formula looks strikingly familiar to the first formula. There are just a few subtle changes. This formula says the slope of the tangent line at a specific point, a comma f of a, is equal to the limit as x approaches a of f of x minus f of a all over x minus a. So we're focusing today on this new formula right here. Okay, so I have our good old PQ graph. When we derived the first formula, we did so by using this graph. So I cut and pasted it onto this packet. And so here, right here, we have P. P is going to be our fixed point. Q is going to be a nearby movable point. And we're going to identify the coordinates at P and Q. But this time we're going to do it a little bit differently. So at P, I'm going to call this value on the x-axis A. I'm not going to put it in terms of x. This is actually going to be a numerical x value, which we're going to call A. So if the x value here is equal to A, a real number, then its y value we're going to call f of A. So the coordinates at P then are A, comma, function evaluated when x is a, f of a. Okay, now Q, on the other hand, we are going to call the x value at Q x. So we're eliminating that whole h factor. We're not going to do a plus h here. We're just going to call this x. And so then the y coordinate at Q would be function evaluated at x. So the coordinates here at Q would be x, comma, f of x. Okay, so right now, if we drew a secant line through P and Q, and we used good old Algebra 1 to find the slope of that secant line, it would look like this. Slope of the secant line would be y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Specifically for our graph, let's actually change colors here. Let's label this as our x sub 1, y sub 1. That's 1 point on the line. And then we'll label this as our x sub 2, y sub 2. So following our formula, y sub 2 is f of x minus y sub 1 is f of a all over x sub 2 is x minus x sub 1 is a. So this guy right here is going to be the slope of the secant line through P and Q. But we're trying to find slope of a tangent line, a second formula to find slope of a tangent line at a point. So now what we're going to do is, in order to have the secant line approach the tangent line at P, here's slope of the tangent line at the point A, f of a, we have to let Q slide down toward P, which is going to force x to slide toward A. Much in the same way in our first formula, h approached 0. Now x is actually approaching A. So for the secant line, to become the tangent line, we're going to write it like this. Slope of the tangent line at P, so at the point A, f of A, right here, is going to be equal to, well, I'm going to click and drag this formula down. It's still the slope of the secant line, but we want to find that as the x slides toward A. And so we're shrinking this distance. X is sliding toward A, Q is sliding toward P, and the secant line is coming into its limiting position at P, which is the tangent line. So this right here is the derivation of our new formula. Okay, so how do we use it? Well, let's take a look at example 1. Example 1 says, use both formulas above, so this guy and our new one, to find the slope of the tangent line to f of x equals x squared at the point 2, 4. So here's the main part of the problem here, our function and our point. Okay, so the first way is what we already know. So let me kind of slide this over here. This is the way we already know how to do it. I'm going to slide this up. So this first part here is just nothing but a recap. We start with the old formula, slope of the tan at the point x f of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so our next step, using f of x as x squared, we would have the limit, and then we would have f of x plus h would be x plus h quantity squared, minus f of x, which is x squared, all over h. If you plug 0 in at this point, you're going to get 0 over 0, so we try to do some algebra here. I FOIL out my quantity to x squared plus 2xh plus h squared minus the x squared, bring that along, all over h. These x squareds are going to drop, leaving me with the limit as h approaches 0 of, out of the top, I factored out an h, and I'm left with the quantity 2x plus h. This is all over h. And here go the h's. There is 0 over 0 being eliminated. So now when I plug it back in, when I let h be 0, I end up getting 2x. So this function of x, is going to find the slope of the tangent anywhere on the graph of y equals x squared. We want it specifically at the point 2, 4, so we do that extra step. Slope of the tangent at the point 2, 4 is equal to 2 times 2, which is 4. So this is the old way. This is the way we've been doing it. And for my visual learners, just to remind you, what we found is that if you graph the parabola y equals x squared, and you go to the point 2, 4, and you draw a tangent line, the slope of that tangent line is positive 4. Okay, so let's tackle the new way. So this will be our new way to do things with our new formula. And so I've already written the formula down from right here. So I'm just clicking and dragging this formula down here so that I can show you guys how to use it. Okay, so you have slope of the tan at the point a f of a is equal to limit as x approaches a, f of x minus f of a over x minus a. Okay, here's what's great about this. This method basically eliminates this step here at the bottom of the old way. I'll show you how. So we're going to start with slope of the tangent line at. Now, we actually have a point they gave us, 2, 4. So we're going to go ahead and let the a be 2, and f of 2 we know is 4. So the difference is here we plug the point in right away. Here we did not. We left everything in terms of x. Okay, so now you got to remember, everywhere you see an a, you're going to replace it with a 2, because that's what a is. This is the x value of the point of tangency. That is a. All right, so this is the limit as x approaches 2. A is 2. Okay, now there's one part here. F of x does want my function in terms of x. So let's go up here and grab that. F of x is x squared, so I'll put that here. Minus. Okay, f of a, we know f of a is 4. So x squared minus 4 all over x minus a. So x minus 2. And now we have a limit to solve, much like we did over here, but there's no h's in this one. Okay, well, if we substitute 2 for x right now, we're going to get 0 over 0, so that's a dead end. We have to keep going. So the limit as x approaches 2, I can factor the top into x plus 2, x minus 2, all over x minus 2. The x minus 2's are going to cancel. And now I just have the limit as x approaches 2 of x plus 2, which is equal to 2 plus 2, or 4. Same answer as over here, but much different looking problem. So this guy keeps everything in terms of x up until the very end, and then you plug the point in. This guy kind of does it along the way, and the 4 spits out because we use the point along the way. I will say that the reason I'm teaching you this method over here is because in this lesson, later on in this packet, we're going to be talking about something called one-sided derivatives. And one-sided derivatives are so much easier to do when you use this formula as opposed to this formula. So that's why we're learning it. Okay, so for the assignment, for the mastery, if you turn the page, I've got 10 problems here that are going to ask you to do parts A, B, and C here to all 10 of these problems using the new formula. There's one little thing I have to add on here because they ask you to do it in part B. First, let's go through it. Part A says, find an equation for the tangent line to the graph of each function at the indicated point. Use the new formula as studied in class today. So there's that. That's what we just did. Okay. B says, find an equation for the normal line. So what the heck is a normal line? So let's define that really quickly, and we can do it right here. So the normal line, okay, normal line is the line perpendicular to a tangent line at the point of tangency. So basically, to find a normal line, you have to write the equation of the tangent line and then take that tangent line equation and write the equation of the line perpendicular to it at the point of tangency. So why don't we just do number 1 together? Let's just go ahead and cruise through number 1 and go through parts A, B, and C so that you can kind of get an idea of what we're doing here. So I'm just going to blow this up here and write a little bit bigger. So number 1 says f of x is equal to the parabola 3x squared, and the point they're giving me is -2, 12. Okay, so they want me to part A, find the equation of the tangent line. Okay, I can do that. So using my new formula, slope of the tangent line at the point -2, 12. So here's my A. You can even write that A, f of A is equal to the limit as x approaches A, which is -2, of f of x, so 3x squared, minus f of A, which is 12, all over x minus A. Watch out for that double negative there. Okay, if I plug -2 in right now, -2 plus 2 is going to give me 0 on the bottom. And if I plug a -2 here, I'm going to get 0 on the top. So I'm going to try to keep going algebraically. On the top, I could factor a 3 out, and I'd be left with x squared minus 4 all over. I'm going to change the bottom to x plus 2. And then I can factor x squared minus 4, difference of squares, into 3 times x plus 2 times x minus 2 all over x plus 2. And the x plus 2's drop. So now when I plug -2 in for x one last time, -2 minus 2 is -4. And -4 times 3 is going to give me -12. This is m. This is the slope of the tangent line to this curve at this point. So I'm going to go ahead and start my linear equation of the tangent line. So now I know y equals -12x plus b. To find b, I'm going to substitute this x and this y of my point in here. So 12 equals -12 times -2 plus b. So 12 equals positive 24 plus b. And if I subtract 24 from both sides, -12 equals b. And my final tangent line equation is y equals -12x minus 12. This is the equation of the tangent line. So this is part A. Now, part B wants me to write the equation of the normal line. Okay, so definition. The line perpendicular to this line at the point of tangency. So we're still going to use this point. But perpendicular lines, let's remind ourselves from Algebra 1, perpendicular lines have slopes that are opposite reciprocals. So the opposite reciprocal of -12 is positive 1/12. So my normal line will have a slope of positive 1/12. Once I get that nailed down, I can substitute x and y to find b. So the y is still 12. The x is -2 plus b. This is 12 equals, let's see, that's going to be -1/6 plus b. And if I add 1/6 to both sides, b is going to equal 12 and 1/6. So the equation of my normal line is y equals 1/12 x plus 12 1/6. This is part B, the normal line. Okay, then part C asks me to graph the function, the tangent line, and the normal line at the indicated point on the same set of coordinate axes. Please use graph paper. I didn't grab a piece of graph paper, so I'm just going to do it the best I can over here. So you're going to draw your y, draw your x. Now I know that f of x equals 3x squared is much like f of x equals x squared, my parent graph, but it's going to be a little more narrow because of the 3 in front. So I'm just going to sketch my parabola. If I had graph paper, I could plot some points. I'm just going to sketch my parabola like this. And then I'm going to put the point -2, 12 on there, because when x is -2, y is 12. So -2, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here's the point of tangency. I'm going to exaggerate that. So then they wanted me to graph my two equations. Well, my tangent line has a y-intercept of -12 and a slope of -12. Well, you can see if I go from this point, if I come down 12 and right 1, and then down 12 again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, down 12 and right 1, you can see my y-intercept is -12. So if I draw this line, it is going to indeed be the tangent line to the curve at that point. Now if I graph the normal line, y equals 1/12x plus 12 1/6, I'm basically going from the point of tangency up 1 and right 12. So if I go up 1 and right 12, I'm here, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Actually, no, that would not be 12. That'd be 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, that's 10. I'm going to be up 1 and over here 12. So the idea is when you draw the normal line, this I really should have a ruler for this. It's going to be perpendicular. So these are going to meet at a right angle. And it looks like the y-intercept here could potentially be 12 1/6 from our work earlier on the normal line. All right, so that's how you're going to tackle this mastery. Good luck with it, and I'll see you for the next video.